So hello everybody. I want to make part two here of chapter 5. I want to add some more stuff. So in your book, by the way, that video was good to watch. There's a video on the e-text right above here, and it is definitely worth watching right here. So they actually go through that calculation there. Okay. All right. So there's a nice little box here called the common mistake, and it's using the wrong discount rate in the annuity formula. And what they say here, the discount rate period that you're going to use, it has to match the period of the cash flows in the annuity formula. Okay, and again, we didn't go over annuities yet, but we will. But I want to give you more, just a general information for interest rates at this point. But you can go through this, and here's the equation for cash flow, which we'll see later on. And they just basically saying is don't treat the annuity as a as a 10-year with a discount rate equal to 6%. So you see that they don't match, right? So the cash flow is 75.86. So this is a good thing about trying to avoid mistakes. So and they say here, you have to take the effective annual rate and convert that to a monthly discount rate, which is what we did here, right? Here's that monthly discount rate. And again, they do call out it as an EAR, okay? All right. So to distinguish between I in your list of symbols and APR, okay, there's really not that much difference. So the I happens to be the rate per period. I'll go back for a minute here. So you see when they plugged in for the rate I, they used the periodic rate. Now, so again, now here this is different than effective annual rate. Banks also quote interest rates in terms of an annual percentage rate, which indicates the amount of simple interest, and notice the word simple interest, earned in 1 year. That is the amount of interest earned without the effect of compounding. So that's an important thing. So this is not effective because it does not include, notice it does not include the effect of compounding. The APR quote is typically less than the actual amount of interest you will earn. To compute the actual amount that you will earn in 1 year, we must first convert the APR to an effective annual rate. So here now they start to distinguish between the two. So suppose Granite Bank advertises savings accounts with an interest rate of 6%, APR, notice how they say APR, with monthly compounding. In this case, you will earn 0.5% a month APR, right? So an APR with monthly compounding is actually a way of quoting a monthly interest rate rather than an annual interest rate. And that would be I, right? Because the interest compounds each month, you will earn. So here you have the 0.5%, okay, each month. And basically, so effectively, you will earn $6.1678. So if you divide by the $1 and subtract 1, you will get an effective rate of 6.1678 right here. So this is how they're calculating the effective rate. So you notice what they say. The 6.1678% that you earn on your deposit is higher than the quoted 6% APR due to compounding. In later months, you earn interest on the interest paid in earlier months. So that's important. It's an important concept, how to get effective annual rate from APR. It is important to remember that because the APR does not reflect the true amount you will earn over 1 year, we cannot use the APR itself as a discount rate. Instead, the APR with K compounding periods is a way of quoting the actual earned income, interest earned each compounding period. So you'll notice here, this is not effective. They're taking the APR and they're finding out what the APR is per month or per period, right? So once we have computed the interest earned per compounding period, right, from 5.2, now we compute the effective annual rate by compounding using equation 5.1. Thus, the effective annual rate corresponding to an APR with K compounding periods per year is given by the following conversion formula. So if we go back to 5.1, let's go back to 5.1. Oh, I guess I got to go back this way. All right, so here is the equivalent end period discount rate, right? And we go back to 5.3, and you can see it's very similar, right? So the effective annual rate is equal to 1 plus APR over K to the K power. So this will give you the effective rate once you're given the, this is a general equation. So as you should be aware, this effective rate will increase with the frequency of compounding, right? And we're going to talk about continuous compounding soon. We'll have the exponential function and we'll discuss that. So here's a nice table right here of different compounding intervals and the effective annual rate. So, you know, here you divide by the number of compounding periods, and here's a nice little example, 2 steps on how to do it. All right, so let's look at this example here, which is a little more complicated. And basically, the firm is purchasing a new telephone system which will last for 4 years. You can either purchase the system for $150,000 upfront, just hand over $150,000, which I don't think I would do, or you can lease the system from the manufacturer for $4,000 at the end of each month. And again, this is you know, you should definitely go over this problem. So your borrowing rate is 5% with semi-annual compounding. Notice it's 5% APR with semi-annual compounding. So the question is, should you hand them the money up front or basically lease the system for $4,000 a month? Which one will be cheaper? They're trying to figure out which one will be cheaper. So here is the payment schedule, right? For over 48 months of $4,000 a month. All right. So again, we didn't do time value of money, but you can calculate the present value, what that $4,000 each month would be worth. Okay. So we got to convert the borrowing to 5% APR, and again, it's semi-annual. They tell you it's semi-annual compounding, right? With semi-annual compounding twice a year, that's 2.5, and then you basically get an effective rate. So here's the effective rate, and there's another way of getting the effective rate of just doing it with equation 5.3 here. So you could either use equation 5.1 or 5.3, right? So this will give you now the monthly rate, effective, and you can get once you get that effective rate, everything's got to be in month because you're paying per month. Is that correct? So the present value would be $173,000 if you basically paid $4,000 a month. And here's using Excel, which we'll do in class and go over that. So so anyway, paying $4,000 a month is $173,867, and $150,000 is what you would pay up front. And they say it's better to pay the $150,000 rather than lease it, but I don't agree with that, only because you could take that $150,000 and most likely invest that in some other item. I'm a true believer in never parting with your cash. So basically what they're saying is a 5% APR with semi-annual compounding, basically to repay $4,000 a month. It's like saying you can borrow $173,867 today. All right, so we'll stop there, and we'll pick it up again. There's a nice video here you should watch also.